Welcome to Major Work of Kindergarten Part 2. This is a continuation of the first session focusing on the major work of kindergarten. During our first session, we looked at counting and cardinality and the different problem types involved with addition and subtraction at the kindergarten level. Today's objectives are to identify the major works of kindergarten, to explore number relationships and base 10 concepts, and then to look at a learning progression of lessons, strategies, and activities related to these concepts. Before we get started, let's review the major work for kindergarten. This document was created by DPI, and there's a major work document for every grade level through high school. The document outlines what are the major areas for each grade level for their understanding, and then what are just the additional areas for math. The major areas of mathematics in kindergarten are counting and cardinality, operations and algebraic thinking, and numbers and operations of base 10. This means that these areas are absolutely essential for students to be successful in mathematics in the current year and in future years. Versus the additional clusters, which are still things that need to be taught at the grade level, but we are not going to give the same attention, the same emphasis to. This is a great document to use when you're trying to determine what to focus on for remediation, or if a parent's asking you how they can help a student, these are the areas that they can focus on. This is also for future years or later years. If a student comes to you with gaps in understanding, you can look at this document to kind of try to figure out what gaps you need to fill in. In our session 1, we focused mainly on counting and cardinality, and then understanding those different problem types for addition and subtraction. Today we're going to talk about our remaining standards that we didn't originally look at in operations and algebraic thinking, and then look at our numbers and operations and base 10 concepts. All of the standards that we're going to talk about today are somehow related to base 10 concepts. So let's talk about what is base 10. So what is base 10? Base 10 is a uniform system for representing all the numbers in our number system just by using 10 digits, 0 through 9. Each digit in a number represents a value that depends on its place. So for example, the value of the 2 in the number 12 is different than the 2 in the number 21. Each place in a number is 10 times greater than its place to the right. So the number 2 and 12 versus the number 2 and 21. The number 2 and 21 is 10 times greater than the 2 and 12. So why does all of this matter, and how does it relate to base 10 in kindergarten? Teachers at the kindergarten level are actually the ones who are laying the foundation for all place value throughout a student's education. And teachers do this by drawing special attention to the number 10. And a lot of times we are already doing that by using 10 frames in our classroom. The standards that we're going to look at today are asking students to decompose 10 into pairs, or to find the missing number needed to make 10. And then another standard that we will be looking at today is asking students to start to view 11 through 19 as 10 ones and some more ones. So here's the learning progression that we're going to look at today. The first thing that we're recommending is starting by looking at the number 5. Students really need to have a strong understanding of fiveness, or the number sense related to 5. So they need to understand all the different ways that 5 can be broken up, that all of the different situations where you can add to make 5 or take away from 5. If students have a good understanding of 5, it's going to lead to the good understanding of 10. And if you think about it, these two numbers, 5 and 10, are the friendly numbers that we typically use when we're adding and subtracting or multiplying or dividing. These are numbers that are easy for us to work with. These are also numbers where if we were subtracting a 2-digit number in maybe 2nd or 3rd grade, for example, 29 minus 39, or sorry, 29 minus 19, we might modify those numbers to say 30 minus 20, because numbers that end in 0 or numbers that are a multiple of 10 are typically easier for us to work with. So at the kindergarten level, we are laying the foundation for that later understanding. So like I said, the first step of this is working with 5. The next step is working with 10. Once students work with 5 and 10 and really have a strong understanding of these two quantities and know all of the different ways to make up these two quantities, then we extend our learning to working with 11 through 19. And here we're composing and decomposing numbers into 10 ones and some more ones. I really want to point out the language right here. In 1st through 5th grade, when we look at place value, the language says looking at groups of 10s and 1s, versus here it says 10 ones and some more ones. That's because we're not unitizing the 10 at the kindergarten level. That means we are not regrouping that 10 into a single unit. We're just moving the single objects of 10 objects and seeing those as 10 and then adding some more ones to make up 11, 12, 13, etc. This is a big difference. You're going to have to be careful with the manipulatives that you use, careful with the strategies you teach, because we are not, like I said, unitizing that 10 into a single unit of a 10 or of a 20. All of these standards that we're looking at today are all pretty much related to 3rd quarter kindergarten concepts. So pretty much session 1 that we looked at focuses on 1st and 2nd quarter. This session is really going to focus on 3rd quarter concepts. So like I said, we're going to start by looking at operations and algebraic thinking and looking just at those decomposing 10 or decomposing 5 standards. So the first thing you're going to want to do is to understand 5. Think of all the ways you could break apart 5 or all the ways that you can compose and decompose 5. You can do this by a spill and count activity, by repeatedly spilling a cup and seeing all of 5 objects and seeing all the different ways it makes 5. 1 and 4, 2 and 3, 5 and 0. You can also develop an understanding of 5 by having 3 different color cubes in a bag and repeatedly pull out 5 and see for this one it's 2 blue, 2 yellow, 1 orange. Put the cubes back, see another way for making 5. You could also ask students to draw 5 on a grid paper using 2 colors. How many different ways could they show 5 on the grid paper? Or do some missing parts. And this goes back to that add and unknown problem type that we looked at during session 1. So for example, you might have a long strip of construction paper divided into 3 areas, and then you would have an index card taped to the construction paper that would flip over as a flap and hide the last area. So in the first section you would say, I wish I had 5. And then in the middle section, you might have 5 stickers or 3 stickers or 3 dots. And then in that last section, the students would have it covered and they would try to figure out what is the missing part. Once students have decided what they think is the missing part, then they would lift the flap to reveal the actual missing part. Here's another way. The students could take turns working with partners. A partner would have 5 chips. The partner would show some chips and have the rest of the chips hidden under a cup. The other partner's job would be to figure out how many pieces or how many chips are hidden under the cup. Those are just a couple activities to developing understanding of 5 with composing and decomposing numbers. These activities could also be used for understanding 10 by just changing the quantities 10. Here's some more activities that can be used for understanding 10, focusing on composing and decomposing numbers. Using toothpick art. Students could use 10 toothpicks or 10 straws and make a design, and then use words or equations if students are even ready to explain what they did with their design. If I was using words to describe this, I might say 3 and 4 and 3. That's 10 in all. If I was ready to use an equation, I might say 3 plus 4 plus 3 is equal to 10. At the kindergarten level, we are not expecting students to write equations. Equations should be modeled for them, and if students are ready for them, students can start to use equations. However, just the concept of addition and subtraction is what is to be mastered at the kindergarten level. Another way for understanding 10, you could put up 3 numbers, for example 5, 4, and 6, and ask which 2 of the 3 numbers can be combined to make 10. And then put up 3 more numbers, 8, 2, and 0. Which 2 of these numbers can be combined to make 10? And then the same thing with 3, 6, and 7. Which 2 of these numbers could be combined to make 10? Here's another activity. We talked earlier about 10 frames and also in session 1 about the importance of using 10 frames. Here, students could work in pairs or even alone to find cards that could be matched together to make 10. This activity could also be played as a memory game or as Go Fish, where students are trying to make 10. The last activity is called 10 Frame Tell-All. The students would put some chips, or the teacher would put some chips on a 10 frame and ask the students all the different ways that they can, ask the students to describe all the different ways that they can discuss 10 here, or that they can tell about the 10 frame. I might say, you need 2 more to make 10, so 8 and 2 is 10. Or 10 take away 2 is 8. We can even extend this to say, well, go ahead and describe more about what you notice here. Well, I notice 5 and 3 is 8. I notice that 3 and 5 is 8. And just encourage students to describe this 10 frame in as many ways as possible. So we just gave a couple really quick strategies for composing and decomposing 5 and 10, but the major purpose of this PowerPoint today is to look at numbers and operations in base 10, working with those numbers 11 through 19. These numbers, I'm sure as you've experienced, are so difficult for students, so we really want to give them a lot of variety of opportunities to really develop understanding of these numbers. One caution I want to point out is with the manipulatives and the drawings that you're using to represent these numbers. These type of manipulatives, the base 10 blocks, are probably not a good idea at the kindergarten level, because if you look at those 10s or those rods, they really almost look like the number 1, which is really confusing for a student. Also, we are not looking at 10 as a unit, but at the kindergarten level, we are still looking at 10 as 10 ones. Whereas here, with the base 10 place value rods, they still look like a unit. The other thing that we're showing on the left side, this image here, is sometimes shown in textbooks as quick 10s or just a quick drawing for how to draw 10 and 1s. But again, because we're not looking at 10s as a single unit, we're still looking at them as a group of 10 ones, this wouldn't be appropriate for kindergarten. It's especially not appropriate because that stick there still, again, looks like the number 1, which could be confusing. If you are looking for models to use to represent 10s and 1s, or to represent those numbers 11 through 19, here's some suggestions. 10 frames. This is probably the best model for the kindergarten level because, like we said, you should still be seeing that a 10 is made of 10 single objects. So then students could see the 10 individual objects on that one 10 frame. Connecting links. Because you can still see that each link is its own separate entity, even when grouped together, you could easily see the 10 separate units in that group of 10. One of my favorite things to do is to kind of make a 10 frame using an egg carton. So just clipping off the sections for eggs 11 and 12 and just having a 10 unit egg frame here, or 10 frame here. Another favorite thing to use at the kindergarten level are connecting cubes. The cubes can be connected to form a group of 10, but you can still see that they're composed of 10 individual units. And if I was representing the number 12, for example, I would take one rod of 10 and then 2 additional ones. It's also fun to use bean sticks with students because the students can create their own bean sticks, but they could also still see that each bean separately is placed on the stick and composed together to make a set of 10 ones. And then one of the easiest things to use are our fingers. You can still see that there's a set of 10, even though there's 10 individual fingers. I thought this was really interesting. I found this excerpt from commoncoretools.me. It's a website that was developed by one of the creators of the Common Core State Standards. And in this website, he talks about why it's so hard for students to understand those numbers 11 through 19. And I'm just going to go ahead and read this to you. It says, a difficulty with English is that the words for teen numbers do not make their meanings evident. For example, the numbers 11 and 12 don't sound like 10 and 1 or 10 and 2. The numbers 13, 14, 15, all the way through 19, they reverse the digits or the order of the 1s and 10s digits by saying the 1s first. Also, teen must be interpreted by meaning 10, and the prefixes thir and fifth do not clearly say 3 and 5. In contrast, some East Asian countries do not face these struggles at all with learning the numbers 11 through 19, and that's because their number words literally say 10-1, 10-2, 10-3, and so on, matching their base 10 structure and drawing attention to the role of that 10. So The author of this blog or this website suggests that children could actually learn to say their numbers in the same way that East Asian children learn to say their numbers, in addition to the English names. And I've seen some research on this, and it actually does work by teaching students to say 10-3 as 13, but also teaching them the name of it as 13. And you could do this by saying, boys and girls, today we're going to look at a silly way to count, but it really makes sense. Let's try this, 10-1, 10-2, 10-3, and practicing it that way. It'll be easier for students to make connections. Let's take a look at a strategy for instruction. One strategy for working with these numbers 11 through 19 is to use the 10 frame. You give the students a problem. So for example, boys and girls, I found all of these pennies in my pocket. I'm trying to find an easy way to count all of them. Help me count my pennies by organizing them in a 10 frame. And the students would organize them on the 10 frame, and once they move all of the pennies to the 10 frame, they will realize that they have a 10 and some extras. And then it's easy for students to see 10, 11, 12, 13, 14. They have 14 pennies in all. When doing strategies like this, you can even start by making predictions. Do you think I have enough to fill my 10 frame? Do you think I'll have leftovers? And then actually move them to the 10 frame. Here's another activity that you could do with students. You can almost do this on a daily basis when collecting data or trying to sort students. You could ask students, how many students are wearing short sleeves today? If you're wearing short sleeves, go stand in a 10 frame. And then if there's more than 10 students, they would carry over to the second 10 frame. And it would be very easy to see 10 plus some more students, or 9 students or 8 students lined up on the 10 frame. Here's another game that could be used to develop an understanding of those numbers 11 through 19. The first part of this activity that I'm going to show you is actually to help students develop an understanding of the numbers through 10. This can be done towards the beginning of the year, or this can be done as just a precursor to introducing the numbers 11 through 19. So the first part of this activity is actually for partners. The students would each have their own mix and match board, and then several mini 10 frames would be face down in between the two students. Students would take turns flipping over 2 10 frames and to see if the 2 10 frames could be combined to make any of the numbers on their board. If those 2 10 frames can be combined, those students would put both 10 frames on the board. So for example, if I had a 3 and a 2, I could combine them and put them on my 5. The object of the game is to be the first person to fill their board. If the 10 frames cannot be used, the students leave those frames face up, and then the other student could choose to pick from the face-up frames or the face-down frames. When working with the numbers 11 through 19, you would add to the number of 10 frames face down in the middle. Students would repeat the activity, trying to find a 10 and some more 1s to build their number. Let me repeat that. Students would have to have a 10 and then some more 1s to make their number. So if I was trying to make the number 15, I would need to find a card with a 10 and a 5. And again, if the students flip over 2 cards and they cannot use them, the students would leave those cards face up for the remainder of the game for the other partners to pick from. Let's take a look at some more strategies for instruction. I really like these cards. These are place value cards, and it makes it really easy for students to see that the numbers 11 through 19 are really composed of a 10 and then some additional 1s. I would start by modeling a number, for example, the number 14. To really see that this number is really a 10 and some 1s, you would then flip over the cards and reveal that this is a 10 and 4 1s. You could also move the cards apart to show that it is the number 10 and the number 4. Here's another activity. This one's called Climb the Ladder. I liked to use this one throughout the year. I started off simple, and students mostly only worked on the first 2 rungs of the ladder. I would give them a number of the day, and sometimes I incorporated this into calendar time. And we would take the number of the day and see if we could write the numeral. And then I would ask students to see if they could write a set or draw a set to match that number. Later in the year, as we added on to our strategies, I would add on to the different ways I would ask students to represent the number. As we're working with the numbers 11 through 19, I would probably just pick a number 11 through 19 and ask the student to show me all the different ways to represent the number. The equations are there at the top for those students who are ready to write equations, but remember, at the kindergarten level, students are not expected to write equations for mastery, but they can be exposed to them. This is one of my favorite activities. This is a really neat one found on NCTM Illuminations. You can click on the link on your screen to take you there. This activity asks students to count a set of cows. And what the students could do is they can either count them by ones, or they could round up a set of 10 and click Group on the far right. An alien spaceship would then group the cows into a set of 10, but you can still see that there's really still 10 ones there, and then some additional ones at the bottom. And then the students would tell the computer how many cows they have. One caution I want to note is that with this activity, sometimes there are more than 20 cows. Remember, the only numbers we're working with for counting sets and for decomposing, especially with third quarter, are 11 through 19. So if you notice, if you click on the screen and it's more than 20 cows, just click again and it'll give you a new set. Here's another great game that builds in understanding of those numbers 11 through 19 as a group of 10 ones and some additional ones. This game is also on NCTM Illuminations, and it can be found at the link at the bottom of your screen. When playing this game at the kindergarten level, you're only going to want to play at the level 1. The object of the game is to click on the correct number of octopi or octopuses. So for example, in this example right here, the computer is asking you to click on 4 octopuses and then send them down the chute. Every time I've played this game, I've ended up collecting somewhere between 11 and 19 octopi or octopuses. So then once I've collected all of my octopuses and the time runs out, it shows me the total number of octopuses that I saved. In this example, you can see that I saved, after all of my rounds, I've saved 14 octopi or octopuses. And then I have to represent that on a number line. So again, building in that number line that Common Core keeps mentioning. The neat thing about this is that every time that you play, the top row represents 10 of your octopi that you've collected, and the bottom row represents your remaining ones. So it's really easy to see a group of 10 ones and then some additional ones. Here's an activity called Making Predictions. With this activity, I would give students a pile of counters, and I would ask the students to predict if they have enough counters to put on every one of their fingers. Or if they have so many counters that after putting one on every one of their fingers, they would have leftovers. After students make their prediction, I would ask students to try it out by putting one counter on each of their fingers. That's pretty easy for students to realize that they have 10 counters on their fingers. Then I would ask students if they had enough counters or if they had leftovers. They would check their prediction and then tell me the total number of counters they had. In this situation, it's easy for the student to see that 10 and some more ones, that's 13 counters in all. After doing these activities, I would show students on the board what an equation looks like to represent what they did. I actually like to focus on the bottom equation a little bit better because it's easier to see and it makes sense at the kindergarten level. So I would model that this student had 13 counters in all. That was 10 counters on their fingers and 3 leftovers. Let me restate that to the students too. 13 has the same value as 10 and 3 more. I like the way that's worded or that's configured a little bit better than the top equation, but you could definitely model the top equation as well. I could say 10 on the fingers and 3 leftovers is the same value or the same amount as 13, or 10 and 3 is equal to 13. Another way of representing this is to show it on a math mountain, like we saw it in session 1. I could say that we have 13 in all, that was 10 on the fingers and 3 leftovers. Here's another activity. This base 10 mat comes from the Van de Waal Blackline Master. If you click on this, there is a link to all of Van de Waal's activities online. This includes his little 10 frames, his dot cards, and a variety of manipulatives. With this activity, I would show students that I have some blue bears and I have some red bears. And I would ask students to figure out how many bears I have in all by moving them over to my 10 frames. Students will notice that I have 10 and another 1, which is 11 in all. The last topic I wanted to talk about was calendar time. Be very cautious with how you use calendar time. A lot of the things that we've always done in calendar time are actually not at all related to the math standards in Common Core. So really try to focus on only activities that are related to our math standards currently. The other issue with calendar time is the fact that a lot of times only one student at a time is engaged. So as you're doing your calendar time, think of all the different ways that you can use whiteboards or active engagement strategies to make sure that all students are being held accountable for their learning, not just one student. Another caution with calendar time. This counting method right here, where students track the number of days across the year, is actually probably not a good method. And I think you're probably seeing that right now because each of these bundles really only looks like a 1. And it's very hard to see that the 10s are actually 10s and the 100s are actually hundreds. So my suggestion is that you try a different model. For example, using 10 frames. It's really easy to see the groups of 10, and each unit in the 10 still has its own identity. It's just a cluster of 10 single dots. Another way to do this is to track the days using counting links. When I taught first grade, I used to put thumbtacks across the board, so I believe it would be 18 thumbtacks, and then that way I would hang my links. As I got to a row of 10 links, I would move to my next thumbtack and start a new row of 10. So if I was on the 18th day of school, I would have a complete row of 10 links and then 8 links in my next row. That way students can still see each individual unit in a group of 10. Here's another activity that can be done during calendar time, or it can be done as attendance as students come into the classroom. You would ask the students a yes or no question. For example, do you have a pet? And then there would be 2 charts available. The charts could either be laminated and the students could draw on the charts, or if you wanted to use them for attendance, you would probably want to have giant charts and then have cards with students' names on them that they can stick to the chart. So when students would come up, they would put a sticker or a dot for either yes, they have a pet, or no, they do not have a pet. And then during calendar time, it would be really easy to have a conversation about the data, and it would also be easy to see that we have more yeses than nos, or 13 yeses and 10 nos. As we wrap up today, I just wanted to remind you of the importance of using the NC DPI Unpacking Document. This is the go-to document for a complete explanation of every standard in the Common Core state standards for mathematics. This document gives examples of problems, strategies, teacher and student language, and expectations for what should be mastered by the end of the grade level for each standard. This is the go-to document. One note of caution: if something is not in this document, do not teach it. That means it is not actually in the standards. A lot of times teachers will read a standard and interpret it in one way and teach it in one way and include quick tricks or extra strategies when those strategies and tricks aren't really in that standard. Please refer to this regularly for a complete understanding of the standards. Thank you for your participation.